Welcome, everybody. Hope you enjoyed the conference so far. Say yes. Great. And now it's time to speak about budgeting with PowerPivot. Before that, just a few words about who I am, but very, very quick because we don't have much time. For the ones of you who don't know me, I'm Alberto Ferrari, coming from Italy. With Marco Russo, I founded SQLRally.com. There you will find all our thoughts, articles, white papers, code, and stuff that we write about analysis services, tabular, multidimensional in the past. I'm a book writer, trainer, BI professional. I do a lot of things related to business intelligence, and basically I am fond of BI. I really love business intelligence, and I specialize in the Microsoft BI stack, so I don't know much about all the BI panorama. I only specialize in the Microsoft BI stack, and in the last few years, I have to say that I mostly work with the DAX language on tabular. We wrote the DAX pattern, many books which are related to the DAX language. But today we are here to speak about budgeting. The idea of this session is to try to build together a budgeting solution, so a solution that solves some of the problems that typically come with budgeting using the Contoso database. I stopped using AdventureWorks a couple of years ago just because it's so small, it's boring, and I don't want to sell bikes anymore. So now I prefer to use Contoso. At least I sell different things, and for the demo it works much better because it has a larger set of data. And since Contoso doesn't have data as of today, we imagine that we are at the end of 2009 and we need to prepare the budget for the next year, 2010. And well, in order to prepare the budget, if you are in a large company, you receive information from different branches of your company. By country, each country, for example, can send you information about the budget they are building. And some countries might report data just with a large number. Next year, I will sell 1 bazillion of euros of whatever I'm selling. Some other countries might report data by brand. Some other countries might report data by category. So each country might report data to the budgeting office with a different set of information. And your task will be that of taking all these different data sets, bring them in a unified form, so in a table or in a data structure that contains all the data and can be queried in an easy way with PowerPivot. And finally, once all the data will have a decent shape, so it is at least understandable, it will be time to start working with the DAX language to write some measure and compute some values which make some kind of meaning. The steps in order to prepare our budget will be first adjusting data granularity. As I told you, each country provides data in different ways. So if we take a look at the data model, or at least at what we have at the beginning, you can imagine that we are in Contoso, so we have sales. We have sales for 2007, 2008, 2009. I didn't check. Can you read it from the bottom? Or should I zoom in when I have numbers? Say yes or no. Somebody say yes, but zooming is always a good thing. Anyway, numbers here are not important. Now you can read it. Say yes. Great. In the USA, it works better. People are much louder. And in Italy, it works better too. So we have numbers about sales up to 2009. And then each country sends us information. For example, we have numbers and we are speaking about budget. A budget is not a number, so it's not just one number that tells me how much I will sell. Typically, it's built with scenarios and numbers. So in different scenarios, I will sell different numbers. And the scenarios might be good or bad, or there is a war, there is no war, the war is going up, is going down. There are a lot of variables that people use to forecast and to predict numbers. Since I'm not good in forecasting, I simply built a simple table where I created 4 stupid scenarios, rare, medium, and well done. And I used 2 numbers, minimum and maximum. And basically, I take the sales of 2009 and multiply them by a random number between 0.5 between the minimum and the maximum, just to get some kind of numbers. Believe me, budgeting people typically do the same, but they try to convince you that they do complex reasoning on top of it. And using these kind of queries, I created 3 tables. The first one is forecast by country. So each country give me, for a specific scenario, Greece says it will sell $5 million. It's just one big number. No idea how they reached that number, but this is only the number. And of course, we have a different number for different scenario. Some countries report just with one big number. Some other countries report a different granularity. They say, well, I can be a bit more precise, and I can tell you that I will sell not only one big number, but one number for each scenario and each category. So in Armenia, or in different countries, there are many here, Australia, Bhutan, and so on, each category has one number for each scenario. Other countries, again, might report the same numbers, but they do not do that by category, they do that by brand. So depending on the brand of the product, they tell me that they are going to sell a different amount for different scenarios. So now, at this point, you might wonder why I am not able to force people to report all the data with the same granularity. And if you're asking it to yourself, it means you have never been in Italy. There is no way to convince people to behave the same way. And if you think at the whole world, it's nearly impossible to have numbers all in the same way. So you get all this bunch of data. Here I have them in Excel, and you need to be able to forecast data. In order to do that, you need, first of all, to solve the problem of granularity at the data. Because data is coming at different granularities, none of them is divided by month, and I want to build a monthly budget. I don't want a yearly budget. I want to know for each month how much of each category and brand I will sell. And so in order to divide by month, I will use the previous year sales. And since I need to solve granularity for all the different scenarios, I will take data which is predicted by category. I will divide it by brand. Data which is coming by brand, I will divide it by category, so that all the tables will have the same granularity, which is brand, category, month, and country, of course. At that point, I will have numbers, and I will be able to work on them and compute interesting values. I need to define the data model. So once I have this large table, I need to define a data model on which I can run queries and write DAX code. And finally, the last step will be that of writing some DAX code in order to solve the final scenario. For each of these steps, we will use a mix of PowerQuery, the M language, DAX, data modeling, and shaping of the model. So we will see different techniques. We will not go deep on any of them. The idea is to show you a practical usage of all these tools together. And so the takeaways of the session are using DAX to query your data model, because in order to reallocate numbers, we will need to query the data model using the DAX language, build tables, and then use them in PowerQuery to reallocate numbers. Then we will use PowerQuery both with the UI, the easy way that any Excel user can do, but as it will be very evident at the beginning that using the UI, you don't have the full power of a PowerQuery. By using the M language, it's much easier to write code, which is readable, manageable over time. And so M is my favorite language, is my favorite tool in the new self-service BI arena. And when data will be inside the data model, we will have not finished everything, because we will still have to understand how to create the set of relationships in the correct way and how to use DAX in order to compute values in the correct way. It will not be as easy as you might imagine. Let's start with the first step. We already have the tables with forecast. So somebody gave us a table containing forecasting number, but we need to reallocate them. If the forecast is by country, then the country needs to be divided by different brands and then by month. The forecast by country and category will be allocated by brand, by country and brand, allocated by category. And the big number will need to be allocated by country, by brand, category, and month. So all of them will be divided by month. How do we do that? Well, since we have no idea how to reallocate data over time and over different categories, we will use sales in 2009, the last year, and compute a percentage of sales of each subcategory in order to build a table that will be used to remap the data. Now, the sales are right now in PowerPivot. So we have a PowerPivot data model, the one that generated this pivot table, which we can easily see using the PowerPivot add-in. Here you see we have a PowerPivot data model with the store, sales, product subcategory, product category, date, and the different scenarios. Scenario is already put in the data model. But the data is in PowerPivot, and we want to reallocate data which is in Excel. So our forecast table is here. In order to do the reallocation, we will use PowerQuery. But PowerQuery has no way of querying a PowerPivot data model. So PowerQuery can query an analysis services model, a SQL Server model, can query a lot of different databases, but has no way of querying the internal model which exists in PowerPivot for Excel. So what we need to do is write a query that queries the model inside the PowerPivot model, extracts the information, puts them in an Excel table so that once the data is in Excel, PowerQuery will be able to grab data from there and use it to go further. Make sense? The PowerPivot data model is a tabular model. We need to use DAX to query this data model, and the easiest way to do it is to download and install TaxToDo. TaxToDo is an add-in that you can find on Codeplex, taxtodo.codeplex.com, that lets you run queries against your PowerPivot data model using using the DAX language. Plus, it has a lot of beautiful and interesting features. So we have our data model, and we need to reallocate data. So in order to do that, we need to compute the amount of sales of 2009 divided by country and then by category. So we start by summarizing the sales table by store country. And we can easily look at the result. Here we have only the countries, which is fine. But we are not interested only in the country. We want the country, and we want the category, which is in the product category. Then we need to compute the sales. So we add sales, which is a sales amount. Sales amount is a measure that simply computes sales. One beautiful feature of TaxToDo is that once you start writing DAX, you simply press one key and the code is beautifully formatted. It's perfect, it's beautiful. I would really love if Microsoft did it, but they didn't. So TaxToDo with DAX Formatter working together, they provided this basic feature. Now we have country, categories, and sales. We are nearly done. We need to restrict only to 2009, so we surround everything inside the calculate table, where we say that for the date we are interested only in calendar year 2009. And now we have by country, category, sales. We are missing the month, so we need to do the grouping by month too. So month number. And this is reporting country, category, month, and the amount of sales in 2009. We are still missing the percentage, because sales by itself doesn't mean anything. We need to have the percentage of this country, category, and month, against the total of the country. In order to do that, we add another measure, which is the percentage computed by sales amount for all the categories and all the months. Okay. Missing parentheses. Okay, this is not still a okay, this is not still a percentage. What we need to do is divide this number, divide the sales amount by this number. Let's format it so it looks a bit better. Oh, says it's fine this way. Okay. Okay. So now we have country, category, month, sales, and percentage. This percentage will be the number for which we need to multiply the other table in order to reallocate it. Now we have a beautiful query that returns the right number. We need to copy the content of the query, right-click and then copy. And then in Excel, since the data right now is in just a query, it's a query in TaxToDo. TaxToDo has a specific feature to materialize the result of a query in an Excel table, but unfortunately in the current release it's not working, so I need to show you the slower version. The slower version is that you create a new worksheet in Excel, and then from here you have to follow a very boring procedure, which is go to data, existing connection, then tables. You choose one table, the one you prefer, scenario is fine. Click on open, put it there, and this creates an Excel table that is fed by a table in the PowerPivot data model. So basically I copied the table from PowerPivot and put it inside Excel. The magic comes as soon as you right-click there, click on table, edit DAX. From there, you can edit the DAX expression that is evaluated in order to fill this table. The command is not a table, it's a DAX statement. We passed the query we wrote a few seconds ago, and now we have the query executed in DAX materialized inside Excel. The beauty of this technique is that it works even if you refresh it. So if you refresh the data model, the query is executed again, and it will contain new data. Now, this table will be useful in order to reallocate data which is coming by brand. So we call it allocate by category. Of course, we need to do the same operation, again using TaxToDo, with the brand. So we modify the query in order to take not the product category brand, but the product brand. So in the product, I have the brand, and I put it also here. As a result, this time I have the sales divided by brand with the percentage of this brand against all the brands. By following the very same procedure, you can create a new table in Excel. Go there, go to data, existing connection, then tables, then to any table, doesn't matter which one you choose. It materializes the table, and then you trick Excel editing the DAX content. Okay, and now we have a table containing country, category, month number, sales, and percentage, and another table containing country, brand, month number, sales, and percentage. And of course, we need a third table that contains the division by brand, and category together. So we build all these tables in pretty easy way. I'm not going to use these just because I don't want to spend time showing for the third time the same query. In the meantime, TaxToDo crashed twice. Only twice is good. And I prefer to open another workbook, which is the same as before, but where I already did the first step, which is the allocation ready. So in the allocation, I create a table containing country, category, month number, sales, and percentage, another one containing country, brand, month number, sales, and percentage, and there is a final table that allocates by brand and category together. So I have all different shapes of, all different kind of allocation in the same Excel workbook. And the reason I open a new I use the backup is because this table have a name and it's very easy to make it wrong and subsequent queries will not work if the name is not the right one. Now the data is in Excel. I have data in Excel for the source table. I have data in Excel for the reallocation table. I need to merge them together. And to do that, PowerQuery is your best friend. By using PowerQuery, you can simply load tables from the forecast, load table from the allocation, and merge them together, and then compute values, which you will later feed into the PowerPivot data model. That's pretty easy to do. But what we need to do is first create a PowerQuery table starting from the forecast by country, for example. So in PowerQuery, we go to From Table, and this creates a simple table that loads the content of the table in PowerQuery. The forecast is a number, so we transform it and we say the data type is a decimal number. The name is forecast by country, and this is fine. This is just a table that was in Excel and now is in PowerQuery. You can load it easily, so you can choose close and load to. You can materialize it in an Excel table or only create the connection. We are not interested in creating a copy of an Excel table into another table, but since we want to use this table as the source to join into another table, we only create the connection so that now we can refer to this Excel table from inside PowerQuery. So we only created the connection, and now we have forecast by country as one query in PowerQuery. The country need to be reallocated using both brand and category, because the country only contains the country information, so we will do the match by country and do the reallocation by using the percentage by month, category, and brand. So we need this table, and again, in PowerQuery, we create a new query, which is allocation by brand and category, where we basically only fix the data types. So I never find, okay, here the data type, this is a all number. This is an all number, while sales and percentage are decimal numbers. Okay, country, brand, and category are just text. And this creates another query, allocation by brand and category, that together, allocation by brand and category together. Again, we don't want to load this table, we only want, I say that we don't want to load this table, we only want to create the connection. And so now we have forecast by country and allocation by brand and category as two tables in PowerQuery. The last step, of course, with that of merging them together. And PowerQuery offers you the option of doing that by using, for example, the merge operator. And we say that we want to take the forecast by country, we want to take the allocation by brand and category and use the country from here and the country from there to make the join between the two tables. Of course, because it's a partial join, I will have the multiplication of the two, which is exactly what I want. For each row that contains Greece, I want to have all the rows of the other table containing Greece. Once I click on OK, you see that the result is scenario, country, the forecast value, and then this new column. This new column in PowerQuery contains all the rows which are matching the current row coming from the related table. I'm not interested in having it as a table. I want to expand it. And out of there, I don't want the country. I want the brand, the category, the month number, and the percentage. When I click on OK, now you see that these tables start to have a look which is much better from my point of view, because it have the scenario, the country, the value that was forecasted that multiplied by this percentage will tell me what is the correct value of the forecast for that month, brand, and category for Greece in that specific scenario. But as a percentage, it's not yet very good. Let me rename the columns. This is only category. This is only month number, so we rename it as month number. And this is only percentage. Let's rename it as percentage. Percentage as itself is not the number I want. I want the forecast multiplied by percentage. And again, this is pretty easy with PowerQuery, because I can add a custom column where I multiply the percentage by the forecast. Where is my forecast? Okay. And this is the number that I wanted. At this point, I no longer want to see this forecast, so I can delete this column. And finally, this custom column can be renamed to what is currently the forecast for the column. Make sense? Now, massaging this data in this way, you can you start with a table that does not have the correct granularity, and you bring it to another table that has the desired granularity. We don't call it merge, we can call it countries allocated. Now, you can do everything at this point. You can load it, and at this point, once you start playing with data and modifying data, it's always a good idea to materialize the table in Excel, just to look at the data, look that the numbers are correct, that they make some sense, and do any checking that you might want to do. But in reality, this is not yet what we want. We don't really want this table alone in our data model. What we want is this table which reallocates the countries, plus another table that reallocates the categories, and another table that reallocates the brands. We have three sources at the beginning. Remember that we have forecast by country and category, and by country and brand. So we need to take all these tables and follow the same procedure. I'm not going to show you the details of all these tables. What I want to show you is a slightly different thing. In PowerQuery, in order to load one table, we had to load forecast by country, so to create a connection with an Excel table, then to create another connection with the brand table, and finally do the merging of the two together. If you do that with the UI, so with the user interface, you end up having a lot of queries in that pane, and at some point things start to be not so easy to follow, or if you prefer, not so elegant, in a very geeky, elegant meaning. It would be much better to remove these two queries and merge their content in the last one. This is not very hard once you start learning the M language. In fact, as you can see, I have done a set of steps in order to generate my query. This set of steps is stored in the advanced editor. The advanced editor shows you the M source code that generates the transformation. And this is just source code, so you can simply copy it, then close this part, go to your countries allocated, edit, go back to the advanced editor, and here I have different steps. But you see that the allocation by brand, no, the forecast by country, which is the table I am, is it that? I don't remember, we will see that in a few seconds. The table I was using is forecast by country, which is used here. So all I need to do is define forecast by country here and say the source of forecast by country is this. Then you change the data type, and then here I use the forecast. I'm sorry, I didn't zoom. Basically, I took the lines of the first transformation, I brought them in the last one, and I merged them together. I will need to add a final comma here. But when I click on Done, now I have the transformation countries allocated. It does the very same operation as before, but now it does no longer depend from this. So I can remove it, and now I have countries allocated, and I merge the two queries into the same. This is my favorite operation whenever I have to do any operation with PowerQuery, since M is a simple language but very hard to learn. At least from my point of view, it's not an easy language. It's pretty hard to learn it. So the best way to learn it is to start using the UI, do the transformation using the graphical user interface, and then you look at the final result and you start understanding what is happening under the cover with the transformations. You can do the same with allocation by brand and category, of course. You can simply take everything from here, go to the advanced editor, take the content, okay, all this stuff, then go in the other queries, edit, and do the same operation. So in the advanced editor, you go there, and again, you change the names and merge everything together. I can do that by hand, but it's not so interesting to see the same operation again and again. What I want you to understand is that if you use the UI, what you generate is code which is automatically generated. And automatically generated code is not known to be really elegant code because it's automatically generated. So all the names which are used are not perfect. You need to use a text editor to edit everything, and it is all in one line. It's not well indented. So what you should do at this point, if you are a BI Pro and you care for elegance, is take all this code, open another editor like Notepad++, for example, and write your M code by yourself. So, for example, the full code that you have seen before can be very easily simplified to these few lines of code, which are much, much easier to read. You see that I compute forecast by brand by taking the forecast by brand content from the Excel, allocation category by taking allocation by category content, the Excel table. Then I do a nested join, so forecast by brand with allocation category, doing the merge by country, and then I expand the columns. The same operation I did before using the UI, but with M, once you manually edit it, are much, much simpler and much easier to read. You can simply take this code, go there, go to the advanced editor, put that code, click on Done, and the transformation is the same, but it's much simpler to handle. Moreover, you can load it in the data model and do the same for the countries, the categories, and the brand. So same operation repeated 3 times. And again, I'm not going to follow this step here, otherwise it gets boring. I prefer to close it and go to the next step. Let's see what we have done so far. So far we have built the allocation table, so we have used DAX to query the data model and materialize in Excel the tables. And then we allocated the table using PowerQuery. Using PowerQuery, we started with the UI, and then once the UI shown us how to do things, we went to manual coding in order to write more elegant code. The third step is load all the tables and build the set of relationships. They will be not easy as you might expect. We are here in the allocated step. Okay, In this pane, I have by country, by brand, and by category allocated that generate the three tables. So they start with the three sources and they change the granularity. And finally, I built another table, forecast. Forecast is simply the union all of the three tables. If you look at the advanced editor, I basically take by brand allocated, by category allocated, by country allocated, which are the three tables with the same structure and same granularity. I do a union all, and then I do a small set of other operations, like removing blanks and renaming columns. The final result is a single table that contains the scenario, the country, category, month number, and the forecast correctly allocated. This is the only table that I will load in the data model. So in the load 2, I do not load the table in the worksheet, I load the table in the data model, because now I want to take this table and bring it back in PowerPivot in order to start using this value. Now it is being computed, then loaded in the data model. And once it has finished, we can go in PowerPivot. And here we have the previous data model plus the forecast table. Now we have store, sales, date, product, subcategories, scenarios, categories, and here we have our forecast table. Now, the forecast table by itself has no relationships because it's a table I have just loaded. And in order to use it and project it in any pivot table, I need to start building relationships. The first one with the scenario is very simple. Just drag and drop because I have scenario here, scenario there, and the relationship is very easy to create. I have a relationship with the category, and again, this relationship is easy to build. I don't have the category ID, I have the category description, but that's fine. There is no difference between a string and a number in PowerPivot. So category and scenario are very easy, but then I have a bit more of a problem as soon as I start creating a relationship with the month number, with the brand, and with the country. What's the problem? The month number is not a key in the date table. In the date has all the dates, month number contains only month, and I don't have a correct relationship. So how do I solve it? Ideas, very, very quickly. Computer field, I create a calculated column in the scenario, that is the day at which this scenario, this row in the forecast, this row in the forecast refers. Since I know that it refers to dates in 2009, I can create a calculated column in the forecast table. Where is it? In the forecast table, I can create a calculated column, which is the date of 2009. Then I take the month number and the number 1. In this way, I adjust the granularity. So I force the granularity to be at the day level for the first of the month to which I am referring to. Make sense? Okay. This solution is very simple, it's very easy, and in a few minutes we will see it's wrong. But for now, it's good if we use it this way. So it's the date. Let's rename it as forecast date. And now that we have it, we can create the relationship because we have the forecast date, create the relation with the date, and the forecast starts to work. We need to, at this point, it's always good to start looking at numbers and test measures. So let's go to the forecast and let's build a measure, which is, let's call it forecast, let's call it budget, so it doesn't conflict with the table name. Budget equal to the sum of forecast. And finally, we need to format it as a currency. Now that we have it, we can go to Excel. We have a report where we have sales amount. In the date, well, let's not filter the date for the moment. We have all tables, no, but I should have it as a measure group. Forecast budget. Here it is. You see that it does not change depending on the continent and the store type. Let's remove the continent, but it should fill the date. So if in the data we put the year, for example, the calendar year on the rows, we have the budget in 2009, and if we put the month, we have the budget for individual months of 2009. So it starts to filter, but it does not fill the filter from the product brand, and it does not filter from the country. And this kind of relationship is a bit harder to handle, because right now I have been able to create a relationship with the forecast by scenario, by category, by data. I should create a relationship with the brand and one with the country. And I have two problems here, because the brand is in the product table and the country is in the store table. I don't have a countries table and I don't have a brand table. You have two solutions at this point. The first one is to create a table for the countries, to create a table for the brands, build a set of relationships, and then everything will work pretty smoothly. But if you have many of these columns and the number highly depends on the way you build your budget, this can be a bit boring. The other way of solving the problem is just to rely on DAX. Basically, what you need to do is take the filter which is on the product table, for example. Look at the pivot table. In the pivot table, I can remove the calendar, I can remove the month. I can take, for example, from the product table the brand, put it on the rows, and you see that the budget doesn't change in any way, because there is no relationship, and we know that. That is correct. But what we want to do is take the filter from the brand in the product table and move it to the budget table. I understood. It's 10 minutes that Mark is telling me, faster, faster. I know that, but I'm on time. Yeah, once. Then I say, yeah, I got it. Yeah, I got it. Okay, we have a filter on the product table. We need to move the filter from the products to the budget table. And this is a bit harder to do, but not so hard. So in the budget, instead of simply computing the sum, we do something a bit more complex, like calculate the sum of forecast. Then we want to filter only the brands which are already filtered on the product table. So the filter is on the product table, and we want to filter the forecast table. So we filter the forecast it had to happen that I forget how to write the query. We filter the forecast where inside the values of the product brand okay, product brand contains a row where the product brand equals to forecast brand. This is worth spending a few more words on, because what I'm doing here is I say, okay, compute the sum of the forecast table, and that is fine, but don't use all the rows of the forecast table, only the ones where the forecast brand is inside the values of the product brand. And how does it work? It filters forecast and say, show only the rows where the values of product brand has a row where the product brand equals the current forecast brand. Okay? I know it looks crazy. It's always the case when you start playing with DAX. But the beauty of this formula is that it's able to take a filter from one table and push it on another one. We call them virtual relationships. We do not create the relationship in the data model. We create them in DAX, and they exist only when the measure is being computed. And if I have been lucky, you see that now the budget is being filtered by the product brand. So what I have on the rows is the product brand, and the filter on the product brand is being applied to the budget table. Of course, this works with the product brand, but it still does not work with the store country. So in the store, I have the country, and if I put it on the rows, I have the very same scenario. So what I need to do is modify again this formula and say filter those forecasts. Oh, we can make it slightly easier. Filter the forecast where the brand is there and contains the values of store country, where store country equals forecast country. If I'm lucky, that should work. And now you see that the filter from the country is being applied to the budget, and the filter on the brand is being applied to the budget too. So the relationship is not there. It has been virtualized in the DAX language. It's a pattern that you can use and use in order to compute the budget in an easy way. So far, so good. We still have a first big problem that nobody noticed up to this point, so it means you're not paying attention. This number doesn't make any sense. Because remember, a budget has a scenario. If you don't have a scenario, there is no number that you can show. You cannot sum up different scenarios. In fact, if you remove the sales amount and put the scenario on the pivot table, at this point, I want to see all the scenario. This number makes sense. Medium, medium, rare, rare, well done. Each different scenario has a different number, and there is no meaning of showing the number if a scenario is not selected. So what you should do at this point is remove the grand total by saying if has is filter the forecast scenario, then compute all the value. Let me put another parenthesis. I probably put the wrong scenario here, so I should have used the forecast scenario, or use a different measure that doesn't change much. Okay, let's put the scenario on the columns. Now you see that I no longer have the grand total, and if I don't have a specific scenario, everything is correct. Now, before we move on, let me only format this measure by going on daxformatter.com. Okay. From people smiling, it means you have never seen daxformatter.com. You're right. Go out of there immediately. Now, whenever you have a problem, whenever you start writing code, of course, formatting is a pain, because Microsoft still believes that the text box is a perfect editor for a BI professional. I have no idea why. And so we built daxformatter.com, which is a simple website which has a single reason of being: format DAX code. And the real reason why it exists is because it uses our formatting rules. So if you want to format your code, you do it as we like it. That's very simple and democratic. Now we have the measure, and it works pretty well, meaning that we are able to slice by country, we are able to slice by date, we are able to slice by different numbers, and we are able to take specific scenario. So let's, for example, remove the country, remove the scenario. We can put the scenario in a slicer. Not this scenario, but the forecast scenario, which I lost. Okay, we put it as a slicer, and where is my PowerPivot gone? Okay, you align it manually because there is no other way of doing it. It is about to crash, but I hope it lasts for a few minutes. Okay, now we have the budget, and we can slice, for example, by country. And we can slice by month. Where is my month? Okay, in the date, more field. We could put the month on the columns, and we have the budget sliced by all the numbers we might want. And of course, numbers change depending on what we want to see. The problem is that it is still not perfect because it doesn't work exactly as I might want. In fact, even if it works by month, it works by brand, it works by category. But for example, it doesn't work by color. If you put the color here, you see that the same number is it should show always the same number. Why doesn't it do that? No, probably because there is a relationship between the color and the brand. So let's use something different like the store. Okay, if we slice by continent, it should work. If we slice by country, it should work too. But as soon as we add the state, you see that the same number is being repeated again and again and again. So all the rows will have the same value. This is somewhat correct because we do not have a budget by state. We only have the budget by country. So by state, we do not know what number to show. With that said, it makes no sense to always show the same number. Worse, if you use this number in a more complex expression and then this number is being multiplied for other values, repeating the same number will probably lead to wrong calculation. And this is definitely bad. So in order to fix it, what you should do is either hide the value, so remove it completely, or do a dynamic reallocation on the fly using DAX. How do you hide this value? If you look at the budget, it's not very easy to understand how to hide it. But what you can do is try to understand when the budget is no longer valid. And you know that thinking at the countries, for example, when you are showing data at the country level, the budget is good. Where you are showing data below the granularity of the country level, the budget is no longer valid. How do you check it? Well, it's not that hard. If you go to the forecast, you can build a measure number of countries, which is simply count rows, not number of countries, but number of stores, because we will compute the value from the stores table, which is count rows of store. And you can then put the measure there. And this shows that in different countries and different scenarios, there are different number of rows in the store level. When you are at the country level, there is, for example, here 11 stores. Here you have only one store. The point is that when you build the budget, because the budget is at the country level, the budget is not valid when you have a single store or a single state, like in this case. Okay? So I have a measure that tells me how many stores are in this specific state. I need another measure that repeats this number, 11, so counts the number of stores for which the budget was built. And if these two numbers are not equal, then I have to blank the budget. Computing the number of the other numbers, so the repeating is easy, because you say number of budgeted stores. Stores is calculate the number of stores, and then I use all on the store table, and then I fix the values for the granularity of the budget, which is the country. This measure computes the number of stores in all the stores for that country alone. Its result, let me remove the month so it's easier to look at numbers. And here I should have number of budgeted store. You see that this always repeats 11. So it doesn't change when you go below the granularity. Okay? That means the budget has been created thinking at 11 stores. If you have fewer, then it's wrong. Now that you have these two numbers, you can easily create another measure that says is budget valid, which is number of budgeted stores equal number of stores. Okay? You can now put the is budget valid measure. We need again to select from there. Okay, is budget valid tells me false whenever the budget is not valid. And at this point, you can easily use this to say that these need to be filtered and the budget need to be valid. If you protect in this way your measure, now you see that by using the budget is clean at this point. Okay? All this is nice, meaning that you can hide the value of the budget in a pretty easy way, hiding the value when you don't want it to show. Yet, there is a last step that I don't have time to type, so let me go for the final solution, because as you said, I ran out of time. Computing hiding the budget is pretty easy. But a final step, which is worth looking at, is not that of hiding the budget, but instead doing a slightly more complex operation. That is, if you go below the granularity, instead of hiding the budget, you can reallocate dynamically the value based on the sales of the previous year. To do that, you only need to create a couple of measures. The first one is very simple. It's sales 2009 that computes, as you might expect, the sales in 2009, because we are in 2010 and we need to reallocate based on 2009. So sales 2009 is very simple. And then I created another measure, budget sales 2009, which follows the same pattern we have seen a couple of minutes ago and computes the sales of 2009 for all the product of the budgeted brand and all the categories, so only the specified categories and all the stores with the country. So it's the same pattern we have used before. This computes the value of the budget in the value at the granularity of the budget. And finally, you simply divide one by the other. Sales in 2009 divided by budget sales in 2009. These measures look complex, but in reality, they are very, very simple to look. You see in this pivot table, I am at the continent level, Asia. Here the budget is valid, and allocation factor is the budgeted sales 2009 divided the sales in 2009. while if I go online, the budgeted sales is higher because I am below the granularity. So budgeted sales is the total for which the budget was created. Sales is the amount of sales, and the percentage is the allocation factor that you need to use to reallocate the budget if you go below the granularity. Make some sense? Great. The last thing that you need to do is simply use this allocation factor to multiply the budget. So here I check if the scenario is filtered. If it is filtered, I do the calculate that we have seen a few minutes ago to move the relationship. And instead of blanking the value, if the budget is not valid, I simply multiply the value of the budget by that allocation factor. And the final result is that I can compute the budget not only at the country level, but at any level of granularity. Knowing, of course, that if I go below the granularity of the budget, I am doing a reallocation runtime at query time. Okay? So we have built the relationship and we have fixed the granularity issue. One thing which is worth mentioning is that fixing granularity is important and need to be done using dynamic allocation. The solution we have seen the first solution we have seen, that of creating the physical relationship with the 1st of January, works, but will prevent you from going below the granularity with the technique we have seen in the last slide. So, time to draw a conclusion, because I guess yeah, I'm only 1 minute late. That for an Italian is absolutely in time. Whenever you have to work with budgeting, of course, it's always a challenging and exciting experience, because every time it's a different kind of calculation. What I try to show you with this session is that using PowerPivot and in general with self-service BI, you have different tools. You have Excel, you have PowerQuery, you have the M language, you have PowerPivot, calculated columns. All these tools complement each other. You don't need to solve everything with a single tool, but use the feature of the tool you have in a complete environment in order to solve the scenario. In general, whenever you work with budgeting, the problem is always understanding granularity. Working at the correct level of the granularity is the key to solve all the scenarios you might have. If you don't have data, original data at the correct granularity, use PowerQuery and bring data at the correct granularity. Once data is in PowerPivot, then you have to detect the granular level of the pivot table, so where you are browsing, and do the calculation again at the correct level of the granularity. In this case, PowerQuery, the M language are really useful, but then when it comes to really compute complex values, DAX is your best friend. It's not an easy language. As you have seen, you can use it to compute very powerful formulas, but of course, it requires a bit of time to learn and master. And I guess that was the last slide, 2 minutes late, which is great. If you have any kind of question, I will still be here for a few minutes, but right now I guess I need to give space to the next speaker, so I will be here offline or outside to answer any of your questions. Thanks for attending.